Okay, everybody, so what I want to do right now is I want to take the idea, the basic idea of grade as we talked about before, which is just rise over run, and I want to make sure that you understand the nuance of the simplicity of this calculation. So the first thing is it does not matter what unit you decide to measure your grade in. You'll see more of this in the last video where I go outside and measure a series of stairs on COCC's campus. But let me just show you mathematically why it doesn't matter what unit you use. So the rise over the run is going to be your grade. Suppose we did a 32% by measuring in feet. So we did 32 feet over 100 feet. Okay. Well, if you're in Europe, you're not going to use feet, you're likely going to use meters. So you might measure a much larger triangle that's 32 meters by 100 meters. Okay. Or if you're using a very, very small triangle to measure the grade of something, suppose you're building a model or the roof of a shed or something like that, you might measure 32 inches over 100 inches. And why it doesn't matter is actually because of the fact that the units are the same. Because in each of these fractions, you have the same unit in the numerator and denominator, which means that the numerators and denominators will divide each other off in all three of those cases, and you're left with 32 over 100, which is just 32%. So it doesn't matter what units you use, so long as they're the same. That's the important thing. What's important is they need to be the same unit. That's the only thing that matters, that they are the same unit. Okay? So I used feet as an example just because we're in America and we tend to measure quite a few things in feet, but it does not matter so long as you're consistent. More on that in day 2 for grade. All right. The runs number. So all the ones I did back here had a run of 100, 100 something, 100 something, 100 something. It doesn't have to be. So for example, suppose I did 32 feet over 100 feet. I could also convert each of these numbers into meters and get 9.7536 meters over 30.48 meters. That's after a quick Google conversion, changing 32 feet to meters and changing 100 feet to meters. This would be the exact same measurements in meters. But notice how this is no longer 100. Don't worry about that. We'll come back to that. And you could also change these into inches. 100 feet is pretty simply seen as 1,200 inches. 32 feet times 12 gives you 384 inches. And then what's fun about this is I went into Google and I actually did the division. I went 32 feet divided by 100 feet. You can see it right here. And guess what comes out? 0.32. And then I did the same thing here. 9.7536 meters divided by 30.48 meters. And Google knows, because you have meters in the numerator and denominator, they're going to divide off, and you're going to be left with 0.32. And 384 inches divided by 1,200 inches. The inches are going to divide off, and the number, the ratio, is going to be 0.32. So when you do these kinds of calculations in a calculator, and you get a decimal like this, the denominator simply has been changed to 1. You've done the division, and your denominator has simply been changed to 1. Pretty straightforward, pretty awesome. Okay. I wanted to make sure we touched on this in the last video. So here's the same Volkswagen Beetle, looking at its grade, its rise over its run. And the idea of rise over run is for every such and such it rises, it runs such and such. So for example, if we drop in a 32-foot height right here, that means it's going to run 100 to generate the 32%. But if we drop in later at 64, that means it will have traveled 200 feet, 64 to 200. And if we go that much further, another 32 on each, you're going to end up rising 96 and running 300. But the three ratios of this are all 32%. So if a grade is consistent, we'll come back to this in point number 4. If a grade is consistent, then for every x it rises, it runs this. So for every 32 it rises, it runs 100. If it goes 32 more, it must have run another 100. And if it goes 32 more, it must have gone another 100. So hopefully that makes sense. And again, this ties right back to what you all know about slope already, probably from your previous classes. And the last point is probably my favorite of the batch, because if you look at this road, let's actually go all the way back for a second to the very, very pretty, simple road that the Volkswagen Beetle sat on in the beginning. Yes. Very rarely do you see perfect roads like this that are tilted at the exact same slope the entire time. Very often they alternate, they change quite a bit. So, very often, what actually happens is you end up with something called average grade. Average grade. And so that a more realistic 32% might look something more like this, where you've got the Beetle, and it starts up, and maybe it goes flat, and then it climbs up again, and then maybe it gets steeper at the end. But the idea is, it goes up 32 somethings, I just put a smiley face to hold somethings, over a run of 100 somethings. I drive this point home in the next video, where I actually make up a ruler based on a piece of paper and a Sharpie I found in my office. You'll see that in a minute. But you see, it doesn't matter. As long as you use the same somethings, they will divide off, and you're left with your 32% average grade. So the idea of grade, the big takeaway is, it doesn't matter what unit you use, so long as you're consistent. The denominator doesn't have to be 100, but you can always write your result out of 100, which is what the percent means. And the real big thing is, very often in real life, the grades are average, which means you have a starting point and an ending point. Over that time, you went up this much and you ran that much. You can actually envision a line right through here as if you straightened it out. And that's the average grade. It's smoothing out the grade so that it has the same consistent, looks more like the Beetle on its perfect railroad grade road here. Okay, so that's the beginnings of what we need to chat about with grade. One more video, I'm going to show you how to actually pull some measurements off a set of stairs, and then I believe you're ready to try your optional during class quiz. So take care of yourselves, check out the next video, and we'll talk to you soon.